Assalamu alaikum everyone, welcome back to my channel, and as always I'm delightful that you came to my video. So in this video what I'm going to discuss about is DC power supply. The topic I'm discussing this is from the book called Electric Devices, and it's the 9th edition by Floyd. The main pages that we are going to read are from page 85 to page 91. So first of all, what is a DC power supply? It is a simple electronic device that converts the AC source into the DC source for our electrical devices. As you know, many electrical devices work on DC power source. So what it mainly works on is the principle that it works on is a rectifier. The one we use is a full wave rectifier. If you want to know why, the answer is simply written here. A full wave rectifier has less ripple for a given filter capacitor than a half wave rectifier. A full wave bridge rectifier is probably the best choice because it provides the most output voltage for a given input voltage, and the PIV is less than for a center tape rectifier. Also, the full wave bridge does not require a center tape transformer. So the full wave rectifier bridge circuit is shown in this over here, this diagram. 120 volt AC source is supplied here. It's simply a source with some frequency and some voltage, and whenever this voltage passes from this primary coil to this secondary coil, uh, it's usually a step down transformer. This coil here is called a transformer, but the one we use is a step down transformer. It's dependent on the number of turns on it and many other factors, but the main one is the number of turns, and it works on the principle of Faraday's law. We are using 4 diodes here. When we combine the diodes in this manner, it's usually called a bridge. So when the voltage from this primary coil moves to the secondary one, uh, it moves as a simple source and turns on 2 diodes at a time. Whether it is moving from this direction, it's going to turn on these two, and if it is moving from the lower direction, that means the negative direction, it is going to turn these two on. If you want to know why, then it's simple that when this diode is on, that means it is forward biased, so is this one, but the others two are reverse biased. For that particular purpose, those two are only on at that time, and the voltage that they require to be turned on is 0.7 volts each. So you can say, when you are practically calculating the voltage, after that you have to you have to simply subtract 1.4 from the main value. These are simply shown one by one, but this one here is a full wave bridge rectifier. As I told you, bridge rectifier is made when there are more than one diodes connected, usually 4. These are as an individual, and this is a bridge rectifier when we combine 4 diodes. So next up is we have a data sheet of different types of diodes here. You can write down their values by watching this sheet about their source, their input, etc., and the temperature as well. So here it's written that the forward current rating must be equal or greater than 250 milliampere maximum load current, and the PIV must be greater than the minimum calculated value of 16.7 volts PIV. The simple formula of PIV is given here. PIV is equal to VP output plus 0.7 volts. Uh, the data sheet here is shown. You can easily read this if you want to read the values of different types of diodes. Then comes the definition of a transformer, and as I told you, in this particular diagram, this device over here is the transformer. It can either be a step down or either be a step up transformer. But for the sake of reading, I'm gonna show it to you. The transformer must convert the 120 volt line voltage to an AC voltage that will result in a rectified voltage that will produce 16 volts plus minus 10%. It is simply the efficiency that that it can either go up this much up or this much down when filtered. For filter purpose, we use a capacitor basically. As you are shown here, this device over here is a capacitor. It's used for filter purpose. So coming back to transformer, a typical power transformer for mounting on a printed circuit board and a portion of a data sheet for the series are shown. As I told you about different values, it's all shown here. This is also an other data sheet. The filter capacitor. What about the, as I told you, the capacitor is used as filter. It's simply written here in some formal words. The capacitance of the filter capacitor must be significantly large to provide the specified ripple. Use equation 2 to 11 to calculate the peak to peak ripple voltage assuming VDC 16 volts. Equation 212 to calculate the minimum capacitance value, use RL is equal to 64 ohm. It's simply the load resistance. When we simulate the circuit, how it ends up is shown here. So you are shown here a AC voltage source with 120 volts and 60 hertz of frequency. After that, there is a transformer here, the diodes are on, there is a capacitor used of 6800 microfarad, and the output is also shown here when it's converted to DC. This is a real life example of what is an oscilloscope and how the wave shows on the oscilloscope. Uh, this is a full wave rectifier wave. As you can see, the ripple here is quite small. I'm gonna show you the half wave rectifier as well. So there you go. These are the full wave rectifiers, and this one here has a larger ripple. That shows that these are the half wave rectifier. That's why the lower the ripple, the better it is for us, as it's for the optimal use for an engineer to make the best compatible device. The PCB layout is also shown here. To print this PCB layout, we particularly go to some software, usually Proteus. That is what I use, and print the layout. After that, we just print it out on a PCB board and do the soldering, etc. To make a proper circuit. Before that, it would be better if you use this circuit on a breadboard, so that you might not waste your PCB board. So it's better if you perform it on a breadboard first and check if all the equipments are in their best form. That is all I could tell you about this DC power supply, but to show you the diagrams again so that you can confirm what I was saying. So as I told you, it would be better if the ripple is less. So the ripple factor here is less when compared to the half wave rectifier over here. But to lower it to another level, we use a filter capacitor, as I described that early, that the capacitor is used as a filter. So this is when the filter capacitor is not attached, and when the filter capacitor is attached, you can see that the ripple is more and more less than compared to the previous one, and it would be of our best use if we use the perfect capacitor that would be required for that particular circuit, so that we can have the least ripple possible. That's all. Hope you have a good day, and thanks for watching my video. I'll see you in the next one.